Hello, and I am back and in the process of making a mess, changing out my resistors in the Eico 1140 box. I ended up doing as much as I could on one of the first assemblies. I'm replacing what should have been 1 watt resistors with 2 watts, and you'll notice that the new ones are so much smaller compared to the older carbon comps, but that's the way they are. Nowadays the newer resistors are able to hold up to a higher wattage. I did miss ordering one resistor here. I'm going to have to, that one was out of tolerance, and I'm going to go over a little spreadsheet addition I made to check out when things are actually supposed to be in tolerance or not. Along with the list of resistors, I made a little spreadsheet calculator. I can enter a value and it'll figure out for me my plus or minuses at 1%, 5%, and 10%. That resistor in question on that first assembly measures out to 730 ohms. I believe that's a 680. It's a blue silver brown, or blue gray brown I should say. Get my meter into range here. It's a 680 at 10%, and it measures out to 738. Going into my calculator, if I put in 680 for my resistance, it calculates my maximum at 10% should be 748. Well, that would make that one actually acceptable then at 10%. So I might end up just leaving that one and not worrying about ordering one, but the rest of these I've been going through have been out of tolerance. Got it should be a 33K here that's measuring 37.4, and a 10% at, let's see, a 33. The max plus 10%, and that should be 36.3. So we are going to, that one's a goner. So just going through and have to do that. And then I also have a large amount of capacitors to replace. So Black Beauties all tested leaky and are out of tolerance. The only ones I'm going to keep are these 3 micas. They ended up testing within tolerance with no leakage. They're all general instrument. Yeah, what's the voltage on them? I believe these are 450s. Oh, 600s. Volt DC 600 on that one, so I'm replacing them of the appropriate rated voltage and capacitance sizes, and go through, and then after I'm done with this, we'll go over some things on the front plate for what I'm going to do for refurbishing that and getting it back into a good looking condition. Oh, while I have the camera rolling, I might as well go over my soldering process for getting these guys done. Get a little more space. I can move this meter out of the way and get it to cooperate, stand up. I'm using 2 items. I'm using a Waller 140 watt. I seem to need something that's definitely a higher wattage for that common terminal ring of copper wire that looks like a solid 14 gauge, and it's really soaks the heat up. And then I'm also using Heathkit GH17A set with the tip at about 22 watts. That one might be good for doing enough heat just to unsolder things. And my next resistor is going to be a blue, gray, orange. So that should be a 68K. Measuring that one on my meter, that comes up at 78.2, so that's definitely out of tolerance. These were originally assembled just by taking and pressing the wire up against the top part of the loop is the common, which kind of makes it easy to remove because I'm just letting my gun heat up on high. Couple of seconds. It takes some heat because that heavier copper solid wire definitely sucks some of the heat away. I'm going to smooth some of that solder down as I go. And all these original joints too, it's hard to make a joint, good solid shiny joint on these because everything's kind of moving around. Nothing's mechanically firm, and as you go through things, if you don't have a really secure mechanical joint and keep it still during the cooling process, it's going to crystallize as it cools, and that doesn't necessarily make it the worst joint in the world if it's not exposed to a lot of mechanical vibration or movement, but in this case it's kind of almost livable. So that gets me my 68K out of the way, and I've got my replacement there. What I'm doing is I'm just grabbing the lead and pulling the paper off so I don't disturb the connection into the resistor itself. I'm going to take the resistor, I kind of want to have it facing colors up, place it through the hole on the bottom, get it about centered on top, and what I'm trying to do to make a little bit better mechanical connection is I'm taking the top lead, wrapping it around quite a bit, give it a cut, get rid of my tailing, try to give it a good squeeze on there. Then I'm taking a little bit of resin flux, which I have a quantity of. Could use some liquid RA or some no clean as well. Even though there's some in the solder, I'm adding a little more because these joints do have some solder on them still as well. And I heat the gun up for about 10-15 seconds, let it get good and hot. Little tin on the tip. It's like I got a good shiny joint right there. I'm going to pull away, and if you notice, that thing just, I don't know how well you saw it, but it just crystallized immediately after I pulled that away, and it's not because I didn't get it hot enough. It was melted. It was just that there's just the tiniest bit of movement, and that's all it takes. And the bottom connection, These, since these are just passed through, it's also not a great mechanical connection, so I'm not sure if this was a kit built or factory built originally, but all the original joints are either a little low on solder or crystallized as well, and I really don't want to wrap the wire around that bottom connection because that would just make it harder to take the resistor out in the future. So I'm just going to continue that process, and as going along with the rest of the resistors I have to place, and then getting along to the capacitors as well. So we'll follow up when I am done with this, and then we'll go with the refinishing the surface of the cover plate and then the reassembly. And I am back and returning for the final modifications, assembly, and testing of the Model 1140. We are done with refinishing the cover plate, and if you've noticed from my absence, I've been gone for a while doing other things that are seasonally necessary to do when it's warmer and not rainy out, and enjoying some other hobbies as well. But now I want to get back to this. I've got a good rain day to work on a few things, and I'm going to cover what I'm going to do as far as modifications on this and some of my choices for changes. Now, one thing this epoxy on the cover plate has had a chance to set up for probably a good month or so. I found this stuff to be fairly durable and pretty resilient as far as its adhesive properties. I do have a mix. This was the mixing cup I used for this particular epoxy, and it has some residue in the bottom of it, at the bottom of the cup. There's a small amount of epoxy. One thing I've noticed that I can kind of scratch it or indent it with my nail, but it takes quite a bit of effort. It still holds a pretty good shine, but one thing I've also noticed is distorting and bending the bottom of this cup does not release the grip of the epoxy from the plastic at all. It does not really want to come out in chunks or flakes or anything. It's basically staying and really adhered to the plastic on the bottom well. So I am judging by that this is I can't really even, off the residue that was mixed on the side of it, I can't really even peel it off well with a fingernail. So I just started to right there, but it takes a bit of effort, and I had to start an edge to it, but it's still fairly adhesive on a clean surface, and more likely than not it's going to be a good choice to do something to seal a panel or something like this from effects of corrosion and mild abrasion over time. Will it get scratched? Sure. But one thing it will do is it'll keep oxidation from getting to this refinished surface, and it'll hopefully help that paint from fading over time as well, and any smudges or fingerprints that you put on here should be fairly easily able to be wiped off. One thing I'm planning on doing, though, is the original hardware for the outputs in this. These are the two original binding posts. They're non-polarized, color-coded, just black. Polarity really doesn't matter on any of the capacitors. They're all non-polarized capacitors in here. And the resistors, it doesn't matter as well. The one thing about these binding posts is although they do allow for a wire attachment on the inside, a small hole drilled through them, most times most people are going to put some sort of banana plug into these particular posts, and this is a 4mm size post, but one thing I noticed about it is inserting a fairly standard 4mm banana plug, that's as deep as it goes. It maybe gets about halfway up the barrel of the banana plug. And does it make contact? Yeah, it's got a little more exposed surface than you'd probably like to see. And I was looking at some other choices I had for banana jacks like this, binding post combinations, and I have some I purchased for some other projects. This one also does have a holes drilled in it. It has a little bit larger profile of a mounting size, so the hole would need to be changed on this panel. In this particular instance, the jack goes in a little further, or the plug goes in a little further to the jack. Makes a bit better contact. There's still some exposed area to it though. And one thing I was thinking of, most 9 out of 10 times I'm probably going to be using this item with something, these particular cords have a small hook clip on the end of them. I'm going to be using something like this to attach this into a circuit to have it sit there for a while as a substitution device while I'm monitoring or adjusting a circuit to change values and see what happens to it. In the meantime, they'd probably like to get the best connection possible inside of the box. And another selection of jacks I have are some flush mount panel jacks. They have no protrusion, or little or no protrusion from the panel as far as the mounting profile, but they do have a very good contact that takes in all of the banana plug, or jack, yeah, plug I should say, in it. So this one should have a fairly low resistance connection. This one already has a little tab on it. I can change tabs, or yeah, there's going to be a difference in the hole size. Not much though. I can maybe even reuse the original tabs that are soldered onto the connections inside. And the nice thing about this one is a lot of the jacks on meter cords that we have nowadays are, in case it's something where I wanted to make just a temporary prodding connection and use a meter cord, these particular jacks will accept a connection like that. So it kind of makes it universal going forward. The only thing it does do is eliminate the possibility of hardwiring a wire onto the panel, but I think in most instances that's not going to be necessary for my use. I mean, to other people, you know, this is my unit. I'm going to do with it as I wish. This isn't the be all end all or final judgment. That anybody can add any type of connector they might like to the front of these for their unit. And also, I'm not worried about keeping this as a stock museum piece restoration. It's really not that valuable item. I'm just looking to use it as a functional device for troubleshooting other items I'm working on. So going forward, I'm going to need to drill out my mounting holes for these particular connectors, and I'm going to keep, along with the third added jack, this one's just a standard banana jack somebody added on for some unknown reason. It just parallels with basically the common connection. So I'm going to remount this as well just to fill that hole in, and it gives me another option for connections if possible. And also I have some work to do on hardware, which I'll get to next, but for right now I'm going to just drill out my holes and go through the process of mounting the newer connections. And I am back on camera and have returned. I was doing some calculating in my head as to what type of cutting instrument to use to drill out the holes for these particular jacks, and going through things with a cheap set of calipers here, set to millimeters and zeroed. I came up with a diameter of, in inches is 0.046, and millimeters 11.8, so it's just under a ½ inch. The top flange that's going to hold it in place and keep it from mounting through is a 0.54. And regular drill bit sets, at least the one I have from Ryobi, this size is close to a 7/16, but just under for that thread. Doing the measurements and math for division, my size in a 7/16 would be about a 0.435 0.5, and that outside diameter is 0.45 on the threads. It just 0.45, 0.46. It's just a little small. Half inch seems to be just a little too big. It would kind of wiggle around a lot, and it wouldn't leave a lot of the flange diameter on top to catch and hold this thing into place. So I was considering my other options for drilling holes, and I kind of realized that one of my trips to the United States' more favored cheap tool store of Harbor Freight, which I am not endorsed by in any ways, shape, means, or forms, I managed to pick up a Warrior brand titanium high-speed steel step bits. Now it says titanium, but these might be titanium coated, if that, or if not, maybe just anodized with something. It says titanium coated drill bits, but bottom line is these are just they claim to be high-speed steel. They are made where else? I'm going to something about an item like this is it's Harbor Freight tools. In general, I just put in my mind that if I get 1 or 2 uses out of them, I'm happy. They're not really expensive. They're not really high quality, but more likely than not, they will get the job done for a couple of uses. And then after that, if you get a long life use out of them, you've done very well for your purchase. So this particular smaller bit out of the set has a good assortment of step sizes. I'm gonna have to try to focus in on this a little better here, but here we go. It's upside down. But anyways, 1/2 inch is the largest size. The next step right down from that is a 15/32 and a 7/16. That 15/32 seems to be the sweet spot for the particular mounting hole for this. And if I measure it out, it measures out to a 0.046. Doesn't have that last decimal place for 1,000th. And the thread size, if you look, is a 0.046. So that is, oh, I gotta refocus here. I'll refocus and zoom out. But anyways, that's the sweet spot right there. That's 0.46 on the bit. So that would give me a very good contact area. And what I did is I kind of went outdoors to play around with this thing and came up and drilled a hole just to see how it would work out. And lo and behold, it is a very nice fit. The fastener in the back side will capture it well in the back and the front. It's very close to the threads. They're almost to the point where they're scraping, but not. So it's just a very nice fit for that hole. So at this point, I'm just going to go over on camera real quick, drilling the hole out with a step bit. It's not a earth-shattering thing. You can skip through this part if you want. I've got a small handheld drill, and nice part about this is these bits, these particular bits work very well on an aluminum panel. It's very low speed. You don't have to push it for the feed, and just go through and take it down to your desired step for your size. This aluminum cuts very nicely, so it's something you can just walk through with this bit very slowly so you don't make any missteps. There's no reason to speed the process up too much faster. It'll just go on its own. And if you go slow, you're keeping your chips contained to one area as well. That's why I do a lot of things outdoors, because I know it's going to be messy and producing a lot of fluff or something. There's one thing you'll have to keep in mind. You'll have to address any leftover chip shavings on the back side. I'll show you that in a second. If you notice, I'm on the 4th from last step. I want to get to that 2nd to last step. That's my 15/32 size. Zoom in a little more on the end of the process here. On the 3rd step, Definitely don't want to get to that half-inch side, but that second step is where I want it. And that second step just broke through the panel, so I'm going to stop there. But you'll have to look at the back side, and on the back side you're going to see you've got some shavings left over. What you can do is you can take that one bit down and that little bit larger diameter for that half-inch on the next and last step will clean it up. But there you go. There's two very nice holes in order to mount the hardware. There's enough space between them so there won't be any interference, and it'll just give it a desired connection that I want in order to make the meter more usable for my liking. But like I said, you can go with any type of connection you want. You can keep the old ones if you want as well. So going to do a little tidy up work here and then proceed with reassembly of the rest of the unit. And I don't know if you remember from this assembly on this unit, there was some issues with hardware corrosion on some washers, and I was thinking about replacing them, but what I did instead is I realized that I have a literal solution for this. I ended up getting some rust treatment that is similar to the non-toxic, non-acidic chemical baths, and I figure maybe I can try removing the corrosion I have on the washers, and it did a pretty good job. What I'm going to hopefully do as well is go one step further and do something that might sound a little strange, and I'm going to see if these, after a thorough cleaning and washing off of all the chemical treatment, will take a coating of tin, a coating of liquid tin on them as a plating, as that would, although that rust treatment claims to put a protective coating in it so it can last up to a year, this either has to be painted, clear coated, or something in order to keep things from progressing further. And I figure why not try the liquid tin, so I'm going to try that with one of these washers and see if it takes. I've chosen to do something a little strange, but it hopefully will give some protection over time to the surface under the panel, and it'll allow me also to paint the washers and nut hardware. I noticed there was some corrosion on the nuts as well. I mechanically removed, and I could paint these after installation with a paintbrush with some Rust-Oleum silver paint, and hopefully that'll help curtail any further corrosion. What I did was I found the lowest number index mark for each one of the knobs, marked it on the top of the paper, so that way it'll help me go through aligning things, and then I have to go through my switch decks and set my rotary position switch to those corresponding lowest values. Now these are 90-degree right angled, and they did have a set screw on one point, which kind of helps with alignment, but you want to make sure that you can go through and get the right setting. So I'm going to, luckily you can physically see which contact point the resistor is making, so on that one I need the 15 ohm. I have to my 15 ohm resistor on this deck is going to be the brown, green, black, so I ended up replacing that one. So I'm going to end up indexing that switch to that position. These switches don't have a stop on them, so they can be continuously rotated. So we just need to get that index to the 15 ohm position, the ground brown, green, black. The other one was 15K. So that one's going to be a brown, green, yellow. No, brown, green, orange, I'm sorry. Brown, green, orange, it's that one right there. Luckily my contact is just one position over on that one. I did lubricate all these switches before and the shafts to the... Oh, this one is not continuously... It does have a directional step, so I have to go through all the... index it through all the positions. Okay, we are at the brown, green, orange position. Capacitors, that one won't be a hard one to figure out. It's going to be the micas I didn't replace. The three lowest values were actually still serviceable with no leakage, so no reason to replace those. As far as the capacitor replacements, I chose various model components, mostly due to a price point. They are all at least a 600 volt rated voltage. Some of them I made a mistake of buying some with some shorter leads, so I had to put J-hook extensions on them, but tried to make it look like somebody who knew what they were doing was in here. I ended up bending stress relief points away from the body to keep the bodies and the capacitors. This one was also a very short lead one, so that one's J-hooked on. But I ended up bending stress relief to keep it from cracking the body and the seal on the capacitors and all these, but they all turned out to be fairly nice, and also installed them all so the values are all in a position where they're easy to read, so there's no mystery or fumbling around trying to look and see what the heck the value was on things. So I'm just going to go through and position these, get the hardware on, get it ready to get the knobs in place. And I have the knobs, I should say the switches hand tightened into relative position. They're going to go a certain way as far as the wiring from the original configuration. I remember this wire wrapped around the switch deck a lot and came close to being so tight it almost interfered with things. There's no clearance issues on the new capacitor install, which is good. The resistor decks, I have to reattach this once I get these into proper position, and this is going to be a bridged, unswitched common resoldered onto that connection. These two will take mechanical connections fairly easily, which is nice. That's not going to be a big issue, but I just want to get these switches aligned. So what I'm going to do is, knowing that my switches are set to their minimums and these knobs are all the same, they basically have the adjusters on the back. They're all identical knobs. I'm going to position the knob into place and try to find my favorite little Craftsman screwdriver, or something in lieu of. It doesn't need to be tightened terribly well at this time, so I've got a substitute just to make sure it's there. And this one seems to be in the 15 ohm position already, so I can go ahead and remove the knob and tighten down that set screw for the, I should say, the the nut for this switch. I did make sure that the original lock washers were put on the back side of all these switches in the installation. You see those little washers on there. It's a star washer with the internal star, so it's grabbing the brass shaft very well. So on this one here, I'm going to just take the same knob, since all these knobs are identical. Snug it a little bit, and it's positioned fairly well for the 15 kilo ohm indication, so seems to be a good alignment. Going to tighten this one down. And yes, I will end up leaving a small portion of that masking tape underneath the washer. It's not going to hurt anything long term, but it'll allow me to take a paintbrush, put some Rust-Oleum paint, and cover those nuts a little better. I'll have to solder this guy back onto the ring. I'm aware of that. The capacitors are next. They have the 0.0001 value set on the rotary switch, so I'm going to slug that knob on there, and I am off by a little bit, so I need to rotate that into position. And notice the routing of that wire. That was the original installation. It wraps around to the common on there, and that's pretty much how it looked like when I first disassembled it. So double check my alignment again. It looks to be good. Try my best to not disturb the switch deck. I'm going to double check this one after I tighten it just to make sure. Might be indexed just a bit off, but I think that's going to be close enough. The tape underneath the washer shouldn't make a difference as far as the friction because of the lock washer on the body of the switch itself, but it's allowing for a little rotation if I grab the switch body on the back side of the panel, but I think it's settled into place now that I've wiggled it a little bit. I might do that to all of them when I'm done, and then retorque those nuts. It might be a good idea, because I think that star washer might not be in its original position, so it has to resettle and dig into that brass body on the switch mounting position. And this guy here is set to our open, should be set to our open position, and there's a little bit of rotation that can be done on that. Let me tighten the screw again. Okay. Probably going to take these wires, especially for the connections on the banana jacks, and bend them up a little bit. They're going to need some clearance. They should pretty well go right on top of the studs for these banana jacks. There we go. Let's bend him up out of the way a little. I might actually need to maybe take the switch off to get these wires on, because the slack was so tight That in order for it to get into place, this whole switch body is going to rotate a little. A little more. Okay, that's about aligned. Let me see if I can get this on here, though. Oh, man. Okay, it makes it. Only problem is I have to get the nut on it. There is a nut on the bottom of that, and I'd like to get on there. But that does make it, so, okay. And it is in alignment for the open position, so I'm going to remove this and torque that down as well. And I'll operate everything, operate all the switches a bit to try to settle those lock washers into place, and then go ahead and give them a little more tightening. Should hold the switch on the back side. Okay, I'm going to go through and speed up the video a little bit while I tighten things down. Okay, and here's everything mounted back together on the back. Like I said, I do have to resolder this guy. I'm going to also, in my process of reworking this deck of capacitors on this switch, I ended up removing a lead which I marked. There was one from the capacitor negative here to there, in order to connect things properly. I'll have to restore that. I've got my connections to my two banana jacks on top, and I'm going to just end up putting a small piece of wire in here. It doesn't need to be any critical gauge. I just have a small piece of scrap to put on there, and I'm also going to restore this connection. Even it's basically goes the permanent connection to the negative polarity, or the common polarity on the resistors. So I'll do all of that, and then I'll just put the knobs back on just to be able to give a quick functional test of all the values before I put the final cosmetic touches on the unit. And I'm back after doing a little touch-up paint on the rusty hardware. I took some Rust-Oleum aluminum paint and just rattle canned some, used a little makeup swab like that, and went around covering all the cleaned off areas of corrosion on the fasteners, just to hopefully give them a little future protection. So that'll give it a little bit better look over time probably. And all I have to do now is go through and trim around. I'll wait for that paint to set up a little bit, and then trim around the masking tape. There'll be a small piece of masking tape under the washers, but that won't be of any consequence, because the switch decks are trapped by the star washers on each one between the aluminum and the brass, so they won't rotate in any way doesn't alter the friction on anything. So I just have to finish up doing a little soldering for connections, and then I'm going to go through and remount the knobs. Unfortunately, cleaning up these knobs came into a little issue. I ended up using some degreaser, mild degreaser solution with a toothbrush, and even though I did it, most of the bakelite and the knob cleaned up well, except for the fact that the paint was affected on each one of the knobs in a certain portion. So it's not a huge thing. I'm not going to worry about it right now, but in the future I'll go through and I'll get some white paint, touch that up, wipe off the top portion of it so it's got a good indicated marking. But for right now, it's good enough to go through and finish up assembly and testing on the rest of the device. And here is a final view of everybody connected, tightened and torqued and ready for action here. I ended up using just a piece of 20 gauge solid wire to go through the connection I removed in order to work on the capacitor assembly. I don't know if you remember, the old capacitors were quite a larger size for the larger values for the old Black Beauties. These newer ones work out quite nicely size-wise, and they don't spread out all over the bottom. And everything seemed to connect back together okay. It was basically, I just reused this original piece of bus wire and contact soldered it. Hopefully I got a good enough joint to it'll last over time and it won't vibrate loose. Most of the replacement resistors I did J-hook on top of the ring. I wasn't going to rework any of the old ones that were still within tolerance. It wasn't really worthwhile. And all the capacitors I replaced also, they had J-hook connection onto the common ring. The bottoms I did the same as the originals. And then just going through on a final inspection, like I showed I like to do. I was painting the out of tolerance connectors with that chartreuse UV paint, and just to make sure that I get them all, I'm going to do a quick check and turn off my lighting, and I'll show you a new flashlight I got. And the fun one about this one is even the little tiny dots of the chartreuse paint that I left still show up fairly well on camera. Also, one thing I've noticed, this UV light is strong enough where if you see there's a greenish cast around some spots of the wiring, it actually reveals residue of the rosin flux that was used. There's some little dots with little specks of paint everywhere, and it's kind of nice to have. I'll show you this particular flashlight a little better. It was just a Amazon purchase, but it's kind of interesting that it shows any areas where there's some flux residue left behind, and it might actually be a good tool to use to find any contaminants possibly leaking capacitors on a printed circuit board. And it also really highlights some colors. That red for that jack really stands out as a reddish orange. But it seems like I've got all the components that I marked as out of tolerance are all gone. I tried to clean up the ones that I may have mismarked the first time around, but turn some lighting on. And this particular flashlight I'm using, it's called a I don't know if that's a Walkie light or something like that. It's got a multiple LED source on it. It's got a three AAA batteries for the power source, so it's a commonly replaceable battery. They were provided with it. Wasn't very expensive, but it's definitely a stronger UV source than the smaller button cell pen light one that I had. That one was basically was designed for using to recharge the luminosity of fishing jigs that were painted with a luminous paint to be used for ice fishing. So the only thing left to do is to cut the tape off of here, put the knobs back on, and go through the functional testing and make sure everybody is testing close enough within tolerance. So that'll be the next and final portion of the video. And now for the fun part, the final testing of the meter. I'm going to use my old Greenlee DM860. This is one of my favorites just to do troubleshooting and testing resistances with quick in general. It's not my newest meter, but it's still accurate enough to get the job done. Give this guy a little backing for a tilt up there, and in this case I've got the selector switch set to a short. I've got some short little cables I made up for connecting like a test box to a meter or something like this. Just do some parallel connections, and I'm going to take, not that it matters much, but I'm going to delta out the resistance of the leads and connections on the meter so it gives a good internal. And there's selections for a few different connection functions. We got a short, parallel, resistance, capacitance, and just resistors. So we're going to go, we're just interested in testing resistors. So at this point I am set at the 15 ohm value, and we have 15.07 on our meter. I wonder if the backlight works on this thing. I'm thinking about the continuity. Not sure how to do backlight in this one, so we're not going to worry about it too much. It's fairly visible anyways from the value. The next one is supposed to, oops, wrong switch. Next one's supposed to be a 22 ohms. These are a 10% tolerance. So something like a 22 ohm would be a 24 at the top. 33 is pretty spot on. Like I said, I didn't change all of the components. Stuff that was in 10% tolerance, I left alone. A 47 is measuring out to 46. 68 is measuring out to 68. 100 is measuring 99. 150 is measuring 149. 220 is measuring to 217. 330 is measuring to 340. That's within tolerance. 470 is to 475. 680 is to 730. I'm going to check that real quick for tolerance. At 10%, 748 is the maximum value, so it's still within 10%. Like I said, this isn't a laboratory grade measuring device by any sense. It's just a component substitution box, so I'm not going to sweat that one. 1000 is measuring out to 1038. 1.5 is measuring out to a 1.47. Move this light a little bit to get a little bit of the shadow. There we go. 2.2 is a 2.19. 3.3 is a 3.24 kilo ohm. 4.7 is a 4.66. 6.8 is a 6.9. And the 10K is a 9.9. So those are all markedly within tolerance. So we're going to switch over to the high range here. First selection is a 15 kilo ohms, measures out to 1479. 22 kilo ohms is a 21.7. 33 is a 32.8. 47 is a 49.2. That's well within tolerance. 68 measures to a 67. 100K is a 99. 150K is a 148. 220 is a 217. 330 is a 324. 470 is a 465. 680 is a 679. 1 meg is a 1.09 meg. Close, but still within tolerance. 1.5 is a 1.57. 2.2 is a 2.28. 3.3 is a 3.7. Let me double check that. I don't think that that's going to be an issue though. %, tolerance is a 4.07 on that one. Oh wait, that's a 3.3. I'm sorry. Wrong value. Hold on. .363. Oh, that one's a little high, but if you're substituting a resistor value like that in a circuit, usually something of that value isn't going to make that big a difference in the operation of the circuit, so I'm not going to sweat it. Something else goes wrong, I'll make a note of that one and probably go in and replace it. 4.7 measures to a 4.8. 6.8 measures to a 6.5. Pardon me, the sneezels. The 10 meg is a 10.3, so that's fairly accurate. Only one out of tolerance, but mildly, and it's in such a high range where it's not going to make the difference for value. So I'm going to switch meters now and go to a dedicated capacitance meter. It's one of the ones sourced overseas, but it's, like I said, it's the one thing about it is its only job is to measure capacitance, and it seems to do it fairly well. So I'm going to go with the values that it gives me. It's not my only capacitance meter, and I have even new DVMs with capacitor measuring capabilities, but I'm not going to worry about it too much. So we're going to switch to capacitors now. And a 0.001, it's basically 100 pico. And that's coming up with a 96.7. 0.22 is a 206 pico. Fairly close, Subleton tolerance. These three are the original capacitors, these first three. 470 measures out to a 448, so that's still fairly close. And now we're getting to everything I replaced. The 0.001, which is a 1000 pico. 936 on the meter. The 1.5 is measuring out to, the 0015 is measuring out to 00136. The 0022 is measuring out to 205, 206. The 0.0033 is a little bit on the low side, measuring out to 2981. 47, the 0047 is measuring out to 440. 0068 is measuring out to 6.4 nano. And basically a 10 nano is measuring pretty accurately. 15 nano selected is a 14.05, fairly close. The 22 nano is measuring out to about 19.95 on this meter. 33 nano is measuring out slightly lower, around 30. 47 nano is measuring out to 41. That's a little on the low side. Considering these are new capacitors, there's some tolerance to them, I guess. 0.068 is measuring out to 0.70. The 0.1 is measuring out to 102 nanofarads. That's fairly accurate. The 0.15 is a 157 nano. And the 22 is measuring out to 22.5. So one value is a little bit on the low side. Still usable, still functional. And it's interesting to see the functions for the series RC. If I change it to series RC, go to low and put a 10k ohm resistor in line with it, does change a little, but if I go down in value all the way to 15 ohms, it probably won't make much of a difference between the series RC and the capacitor measurement. which it does not at 15 ohms, so that's good. Going up in resistance makes a difference in the measurement capacity of the meter through like a 10 mega ohm resistor and into trying to measure the capacitor, the oscillator in this thing. And parallel RC will also goof things up a bit. Well, actually, in high it doesn't. A 10 mega ohm resistor would simulate 10 mega ohms of leakage on a 0.22 capacitor on this meter, not even seeing it. It's kind of interesting. You can see that dropping down in leakage. You can see it only starts to really change value once we hit 2.2 mega ohms of parallel resistance. And then the higher parallel resistance we get, the more the value of the capacitance increases with this meter, and that kind of simulates real-life testing conditions on most meters. The more leakage you get, as far as a lower parallel resistance, the higher value it's going to measure. So this is a great simulator to show that particular parameter once you do get into parallel capacitive leakage. 150K, so you notice that's there's a difference on that between, what was it, 226 or so starting out, 150K worth of basically leakage. So that's something to think about. So I just have to get myself some proper. I didn't have the proper threaded screws when this was first purchased. So other than that, I consider this device functional and being able to be used in service. And the one thing I'm looking forward to using it on is I do have to go forward with my final repair of one of my Eico brethren 443 semiconductor curve tracer units. Besides the fault for the driver for the power curve tracer transistor section, there is also a oscillator circuit that basically flashes an indicator light to let you know that the inverse voltage section of the unit, which can provide up to 1400 volts of DC, is functioning, and it's a warning light that's supposed to flash at a visible rate to make you aware that it's energized. I replaced the resistor and capacitor components in the flashing circuit, which is known as a relaxation oscillator. It's an old school oscillator, and usually used in conjunction with a neon lamp and a voltage source to make the lamp flash at a predetermined rate. But even though I use the original component values, the flasher is not operating properly. It seems to be oscillating probably faster than your visible perception can see, and I need to do some adjustment and variation in the components involved, and this is the perfect box for it because I can use this for configuring parallel and series resistance capacitive values in order to find out what a working value might be on that circuit in order to get it to visibly show a flash. So I hope you enjoyed the information and the content provided on this. I know this isn't any type of earth-shattering high-value device. It is old-school technology, but there's little or no information on it out in the world of the internet, so I thought I'd just go through and provide the information as I went along for restoring this device. And maybe you picked up some things that you might like to do, or maybe you have some different thoughts, and if you leave them in the comment, that might also be appreciated because it's something I can think about on restoring similar devices as this. And I hope that you return for more content like this soon, and will also be notified if you subscribe to my new releases so you can see if I did come across any other items I am working on. I hope everybody takes care of themselves, and hope to see you return soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.